So welcome to my Sustainable Energy channel. Today I'm delighted to be in the presence of Kevin Winter. Dr. Kevin Winter, professor at UCT, heads up the water research project, and we've been involved with him the last couple of years. We're here today to conclude the installation of the Victron energy system that I designed together with Kevin's input to provide power for this installation, and we're going to take you on a quick whistle tour of what the Water Hub is all about. And just a quick introduction to Kevin. So Kevin, you might recognize from the days when we had our water crisis, and Kevin guided us through one of our worst water crises we've ever had in our city, and has gone on to build momentum in the Water Hub project. And in essence, okay, so we're just going to pause for a second. So Kevin, maybe you could just give us a quick layman's view as to what the Water Hub's all about, and then we'll just take you on a quick tour so we can see it in action.
Yeah, thank you, Alan, and really do appreciate the support that you've been giving us in terms of bringing our water and energy nexus together. You know, the integration of that is really important. So, which was an old wastewater treatment plant, and we've converted the infrastructure on the site to produce and treat water coming down from an informal settlement using nature-based processes. Very, very simple in some ways, but there's quite a lot of operations and biological processes that are being involved in that. And we'll take you through some of that just now. But essentially what we're doing with that water is using it to safely irrigate vegetables and breed fish, and understand a little bit more about what happens when you use these nature-based processes and the particles that move through it, the compounds that move through it, and how nature-based works. And it's about working with nature, so understanding nature is actually crucial here.
Fabulous. Okay, so in essence what we have here is some solar panels and an inverter providing power to the pumps that drive the system. Obviously this whole system is off-grid, and we'll take you through a couple of photos of just the installation and some of the thought process behind. And one of the interesting things about the project is deciding how to balance energy in storage in lithium-ion batteries and energy in storage in water tanks with gravity-fed solutions. So a kind of dynamic between the two and trying to find the most cost-effective and robust kind of solution.
Great.
Fabulous.
Excellent. Well, fabulous. Okay. You've done this before. Excellent. Excellent.
So today we're just concluding the installation of the electric board. Just a shout out to Rob Thorburn of IMC, Industrial Motor Control, for supplying and donating some of the switchgear, which will help the site to run in a safe and orderly manner. So thanks Rob, to you and your team. We've also just made a contribution, just providing some of the comms equipment just to get everything up and running. But effectively this now will allow us to interface to the pump system. Just have a contactor and some timers here and some programming of the inverter itself to give optimal performance for the pump station that I will take you through now. Okay, so Kevin, will you just take us through how the plant works?
Sure. It's very simple. There's really no rocket science around this at all. It's a very simple idea of taking water which is highly contaminated from an underserviced informal settlement. There are about 7,000 people living further up the hill and very limited sanitation. So the obvious thing that happens is that it is coming off the surfaces into stormwater, finds its way into the river, and comes down here highly contaminated. The levels of bacteria, of nutrients, and of drugs and pharmaceuticals are really very high indeed. That's probably about the easiest way I can actually say it in terms of the concentrations. And what we do is we take up the water from the river, we pump it up, and now what we've got is a wonderful opportunity to use solar energy to be able to do that 24/7 and to allow this water to constantly flow through the system. And if you look a little bit onto the biofilters where I'm sort of pointing now, these are places where at one stage they were drying beds. They're about 1 meter deep. Each of these cells, if you can see them here, about 16 meters long. They're filled with a stone aggregate, and where my colleague is looking there, it is a biochar, and the combination of all of that cleans up the water to such an extent that when it comes to the end of that, there's no bacteria in it at all. And the significance of that is almost about a 99% percentage of reduction in bacteria, in the nutrient levels as well. And likewise, what we're experimenting with here, and the cell that I'm right on right now, is the one that actually is going to be starting to take up all the pharmaceuticals, the drugs, the microplastics and so on are going to be absorbed by being taken up into the sand filtered cell over here. And we needed the energy really to be able to, first of all, pump the water up from the river, but then also to pump it all up to the cell over here.
And Kevin, there are no chemicals in this process whatsoever.
And that's the secret of it too. Well, not so much a secret, but actually, how do we get away from putting chemicals in water? And this is a very important part of actually understanding how to work with nature. And essentially, that's what it is. I mean, nature's been operating like this forever. And we're only starting to learn to understand the sophistication of nature and now mimicking this. And it's what we sort of call biomimicry. And if we can try and emulate what nature does, I think we'll be so much better off in ways of managing water that is fit for a particular purpose. We wouldn't drink this water. It's not for that. It's for other things that are really important. And most of our water that we use is not for drinking. We only, actually, human beings need to drink 2 or 3 liters of water a day at the most. But most of our water is used for sanitation, for irrigation, and for plenty of other purposes. This is what it's trying to do in a decentralized environment, which offers opportunities for people who are living in poverty further up the hill here to engage with an agricultural environment that we are trying to establish here as well.
So just for point of reference, these are your header tanks here, and then the informal settlement in Franschhoek is just in front of us. How many people actually live there? Have you any idea, Kevin?
About 7,000.
Wow. So just from my basic understanding, there's a river that runs down here, and that river is a river that goes into the main estuary, into the main Franschhoek River. Is that correct?
Correct, yeah. The river is called the Stibberville River, and it's a very small stream, but its impacts are significant on a almost pristine river that it has a confluence in at the bottom of our site here.
Right.
And that's what we want to try and deal with. And by the way, it's also comes with it, with winter rains, comes all the plastics coming down here as well.
Okay.
And the site actually offers itself all kinds of new questions. So how do we take that plastic, wash it, clean it, and eventually use that as crushed plastics so that we can use it for insulation of housing, roofs, and walls and so on, that provide a really nice opportunity to reuse in an informal settlement. And we're experimenting with that here on the site as well.
Okay. So just in the distance there is the original building, and that's where we put solar panels on both sides, and they generate about 5 or 6 kilowatts of energy. And then there's obviously a cable that brings the energy up here, and then the pumps are housed in these pump areas over here. And this is what I was alluding to earlier. There's some gravity feeding going on here, so we can use energy during the day to pump the water up to produce a head, and then that water can flow down overnight when we have no solar. And if I'm right in assuming that's one of your charcoal beds there.
Correct, yeah.
So that's actually manufactured from local sustainable charcoal?
Correct. It's from alien exotic species that have been turned through pyrolysis into what we call a biochar. And as that process happens, it is a wonderful harbor or habitat for denitrifying the water. In other words, the bacteria turns the ammonia nitrogen, releases that into the atmosphere, and you reduce the nitrogen into the atmosphere. And of course, I suppose what we're doing kind of in closing, and the very obvious thing is, how do we upscale this? It's an energy component that's really important. It's cleaning water, which is the catalyst to everything we try to do here. And then the opportunities to actually bring the food into that whole nexus as well. But without energy, we couldn't do what we're doing right now. And the opportunity now exists with this new cell that I spoke about here, this new sand filter cell. We should be able to treat about 500,000 liters of water every day from the river. That will make about a 50% difference to the quality of the water in the river. And the big challenge again is to say, how do we do that completely, and how do we divert that river and clean it up completely? And of course, maybe the sort of thing that people are watching saying, why don't you start cleaning it up at the informal settlement? Well, that's growing. Informal settlements are here to stay, and it's really difficult to actually change that scenario.
Right.
There's no easy way to get in there and intervene and service it. That settlement has been going since the late 1980s, and it's only getting worse, and
Right.
more people
Right.
coming into it. Massive challenge.
Right.
Maybe we've got to do other things downstream, learn from what we're doing down here, and we can start to work with the same kind of systems closer to where the real causal impacts are being felt.
And of course, this is not just the South African problem, it's a developing world problem. So we have informal settlements all over the world that could use the same
Absolutely.
process and technology.
Yeah, I mean, really thrilled to have the partners that have emerged out of this particular enterprise. So most of them at this stage are from different parts of the world. My colleague, as you saw just now, is from the United States, but there are Spanish, Dutch, German, English, Brazilians, and plenty of other local universities and municipalities who are starting to see what we're doing here, seen the results most of all, and are starting to find, opportunities to upscale that and to transfer that knowledge elsewhere, which is really what our goal is. We're a university institute. That's our role, open knowledge to try and transfer it.
Well, thanks so much, Kevin, for including us in your project. It is a fascinating one. Very proud to be involved and learning a lot. And we look forward to good things going forward. So thanks again for your time.
Thank you too.
Thank you, Kevin, and your team, and thanks to my team as well. Been a very exciting project to be involved with. There is a part 2 of this video coming out, where we'll be covering some of the more technical aspects of it, including the programming of the inverter, setting up some tank sensors, and perhaps even a bit of Node-RED programming for measuring current sensings, etc. There's more information about the Water Hub, and links are in the description. Please feel free to contact Kevin and his team if you're interested in becoming more involved, and thanks for watching.